So, so anyway, everything is posted for the final exam, the review packet, the problems we're doing tonight, sample final, et cetera, et cetera, et cetera. Your final exam is going to be, first of all, it's next Monday, starting at 5 o'clock. I have found a proctor, and that proctor has told me that they are willing to let you work longer than 2 hours. So in fact, as some of you like to do, you can take your time, and I mean, I'm writing it to be a 2-hour test, but if you need more than 2 hours, she has told me that she will stay, and she'll cut you off at some point, but I think it's going to be pretty late before she cuts you off. So you can probably count on having 4 hours if you want to sit there, but I can tell you that usually people don't get that much out of it after, you know, if you haven't figured it out after like 3 hours of staring at it, it's probably not going to happen. So, anyway, but you will be able to stay late. What's going to happen is after your final, the exams will be mailed to me in Nebraska, and I will grade them as soon as I can, but there will be a little bit of a delay because of the mail and all of that. But I will be able to grade them, and you'll be able to come back in the spring if you want to see your final, or get a copy of it or anything like that, but we won't be able to do anything until then. If for some reason you do not like having your grades posted on my website, on that Excel spreadsheet, particularly when the final grades are coming, feel free to email me. I'm happy to delete your information from that site and just email you personally with the information you need about your grade. There's a lot of people in the class, so maybe it doesn't matter that much, but if you're sensitive to that, feel free to let me know. So that is basically it. We covered section 7.6 last night in the first part of the class, and so that's in pretty good shape now. There's also the 7.5 stuff. Now, in terms of the homework, there's another homework assignment that I was hoping to have everybody do. I may end up trimming it. Actually, I am going to trim it. Let's get specific about it. So I believe the problems I asked you to do are in 7.5 and 7.6. So 7.5, I think I asked you to do number 3, 5, 8, and 14. And in 7.6, I asked you to do number 3 and number 6, right? So I think what I'm going to do is trim that a little bit, okay, make it a little bit shorter. So let's skip number 8 and cross that one off. And let's see, there was one more that I thought we could skip, which was, which one was it? Well, actually, we might be okay. Let's try the other 5. Okay, number 8 is the one that's really the tough one that I'm not going to have time to go over all the material. So 3, 5, 14, and then 3 and 6. Unfortunately, the only one that you can really do real easily right now is this one right here. So if you want to get a head start, I covered 7.6 last night, and you can do number 3 right away. Number 6 actually does require the stuff from 7.5 as well, so you're not going to be able to really do that until I've gone over it tomorrow. Maybe what I'll do is I'll pick one of these other ones as an example or something to do in class tomorrow night, and that'll hopefully make the assignment pretty short and easy. Does that sound fair enough? So anyway, it's not that many problems, but these do take a little bit of time, so you'll want to get started on it. I'm going to, by tomorrow, I'll decide what my phone office hours are going to be, and of course I'll have email contact the whole time I'm gone, so you'll be able to get help from me remotely if you need to. So, sorry about all the confusion. Question? I will try to get the solutions to the final posted. I will have access to my website remotely, so I will try and get them posted. I'll probably post them on like Tuesday morning, something like that. So I'll be in a different time zone, all mixed up. But anyway, so that's kind of where things stand. Somebody has already noticed that some of these problems that I put up on the final exam information sheet look kind of familiar, and that's not by mistake. That is because I just put up some of the same ones again. These are the ones that are from chapters 6 and 7. So if they look familiar, it's because you may have done them before, and that's okay. It doesn't matter if they're still up there again. So you can take a look at those. The sample final would be really good to go over, especially because the format of your final is going to be the same, which is 12 problems. 12 problems on the final. They will each be worth 10 points, and I will only count your 10 best problems. So if you do all 12 problems, I will grade them all and then cross off your 2 lowest scoring problems. Or you can just decide you don't want to do 2 of the problems at all, and then just leave a blank, and then I'm just going to be grading the other 10. So my advice would be to try and do everything, and then I'll just take whatever's the best of what you've got there. So it'll be out of 100 that way. And maybe a slight emphasis on the stuff in chapter 7 here at the end, but not too much. You won't notice it that much, I don't think, because it's just, I mean, there probably will be something from one or both of these sections. I mean, almost certainly I will ask something about the last 2 sections because I haven't tested you on it yet. But other than that, I would expect a fairly uniform coverage of the material. It is comprehensive. I'm going to give you the Graham-Schmidt formulas like I did on the second midterm. I'm going to actually I'm not going to pass out the table of integrals and annihilators separately. I'm actually going to put it on the back of the front page. So you just have it there right off the bat instead of having to keep a separate sheet of paper. So you'll get that. Annihilators, integrals, Graham-Schmidt formulas. Is there anything else I need to give you guys? I think that's pretty much it.
I have a question. For the mixing problem that we did when we had that test from test 1,
Oh,
there was
I said
a
I'd
part
give
of
you
it
the
that you
formula.
gave? So,
Yeah, I
okay.
would give you that formula as well
Okay.
if you need it. So we're making do over here, I think, for now. Thanks for bringing that, though. Wow, that's really big. That's too big for my camera, probably. Anyway, I think we're doing fine. Okay, so are there any other questions related to the exam itself, the final? It will feel formatted a little differently. Basically, it's going to be 1 page per problem. What I'm going to do, the front side will have the question or parts of the question that will add up to 10 points. The back side of each page will be blank and free for you to use as scratch work. So it's just going to be flipping forward through those pages. So you shouldn't need any extra scratch paper, just write on the back of the pages if you need extra room. So hopefully that'll make that a little bit simpler for you. So that's how I'm planning to sort of put it together. Is that okay? All right, so it'll be up in MH 615 starting at 5 o'clock. And you won't even have to listen to a lecture beforehand. You get to start right in. Okay. So this final exam review session, these problems that I printed out, I've got 12 of them here. The chances are I'm not going to be able to do them all. I just think it's going to take too much time tonight. Let me do what I can. I'm also kind of losing my voice for some reason. So we'll have to see how it goes. When I make my first trip downstairs, I get myself something to drink that might help. But I'm going to try and pick the problems that I think would be the most helpful, but actually they're all pretty good. These problems that are in the review session problems are all pretty good to practice on. So do as many of them as I can, okay? So with that in mind, I think I'll just start with number 1 on the sheet. Okay. We ready to start doing some problems? Okay, let's do it. So let's start with number 1. I'm going to come over here. Okay, and in case you don't have it printed out or don't have it in front of you, I'll write down the question real quick. It just asks you to solve this system. X prime equals negative x plus 2y plus 54t e to the 3t, and y prime equals negative 2x plus 4y plus 9e to the 3t. Okay. One of the things that is going to be your challenge on the final is going to be to understand where does this problem fall in the material. Obviously we see it has a differential equation, right? So we can try and figure out, is it from chapter 1, right? Or is it from the later stuff we've done more recently? What would you guys say? Is this old material or new material? Old material?
Let's see.
Any other comments? Old material or new material? Tell you what, let me rewrite it. This left-hand side, which has x prime and y prime, I'm going to write that as x vector prime, right? And then you guys see the first part here on the right side? I'm going to write that as -1, 2, and -2 and 4 times x, right? And then I'm going to put plus 54t e to the 3t and 9 e to the 3t right there. Does that make sense? Okay, let me ask you again. Old material or new material? Definitely new material. Guys, there's more than one differential equation. Chapter 1 was only one differential equation at a time. This is a system of differential equations. In fact, it's non-homogeneous. This is actually the stuff we just learned last night. Okay, I just wanted to practice it again. So this is really just x prime equals ax plus b. So do you remember there's a 3-step process for solving these? The first part is to just solve the corresponding homogeneous equation. So, by the way, one of the reasons why it is very, very likely that I'm going to ask you to do one of these on the final is that it involves a huge amount of material. Think about what you have to do to solve this problem. First of all, you have to find eigenvalues and eigenvectors, right? Then you have to write down the general solution for the complementary function. Then you have to do that variation of parameters process to try to come up with a particular solution. In the process of doing the variation of parameters, you end up having to invert a 2x2 matrix. That's something we also learned how to do way back when, right? I mean, almost every chapter of the course, except maybe the first chapter, almost every chapter of the course is used in solving this problem. So I love this kind of problem, and so make sure that you do these problems on the homework so you get real, well prepared to answer them. Okay? So for step one is where we're going to find the x sub c of t. Okay? Does anybody remember what do I need to do in order to start finding x sub c of t? Okay, good. I subtract lambda from the main diagonal, so I'm going to get -1 minus lambda, 2, -2, and 4 minus lambda. And then what do I have to do with that matrix? Determinant of that. All right, so the determinant of that is -1 minus lambda, 4 minus lambda, and then plus 4. So I'm using the 2x2 determinant formula, which everybody should totally know, AD minus BC, right? Okay, good. So when I expand this thing out, I'm going to get lambda times lambda, which is lambda squared. And then plus lambda and minus 4 lambda would be minus 3 lambda. And then I have a minus 4 and a plus 4, which cancel. Agreed? Everybody comfortable that this is what you get? Lambda squared minus 3 lambda? Does that factor? Mm-hmm. Absolutely. What are my values of lambda going to be?
0 and 3.
0 and 3. Very good. Okay, so we have lambda equals 0 or 3. So this matrix is not defective because I have distinct values of lambda. So I'm just going to take each one of them, and what am I going to do for each of the eigenvalues? Pardon? Right, the null space of A minus lambda I. So in the case of lambda equals 0, I'm actually just finding the null space of the original matrix. Here's the original matrix, by the way. This is capital A, right? can you just already see that that matrix is, of course, not invertible? And if you do EROs, you're going to cross off one of the two rows. Let's say you cross off the bottom row. So then you just have this row vector here, -1 and 2. Can somebody give me a vector that would correspond with that row, -1, 2? 2 and 1, right? By the way, guys, slow me down if I'm going too fast. So the vector 2, 1 is killed by the row vector -1, 2, if you think about it. So we've got our first eigenvalue eigenvector pair, which means we've got our first solution. I'll call it x1 of t, and this is e to the 0t times 2, 1. E to the 0 is just 1, so I'm not going to write it down. Okay? The next eigenvalue is 3. This one I have to actually do the work. I'm going to subtract 3 from the main diagonal. So I'm going to get, just going to be brief about it. If I subtract 3 from the diagonal, I'm going to get this matrix right here. So the -4 and the 1 are what I get after I subtract 3 from the main diagonal, right? And this matrix has to be not invertible, right? So I got to cross off a row. I'll cross off the one that's got the messier numbers. And can somebody give me a vector that is killed by the remaining row, which is -2, 1? 1 and 2, exactly. So v equals 1 and 2, very good. So then I get my second solution, which is e to the 3t times the vector 1, 2. Now keep in mind, you're getting partial credit all the way along here, right? So one of these problems is a big 10-point problem, right? You've already got maybe 3 or 4 points just getting through this first step, right? This is an important part of the problem. So the next thing we can do is actually write down the conclusion, which is the x sub c, right? And you're going to get blocked by that podium before long, so if you need to move, go ahead. I'm going to use this space though, that's all right. So the complementary function is going to be c1 times 2, 1 plus c2 e to the 3t times 1, 2. Okay, so this is an important piece of the solution. Make sense? So that's step 1. Now step 2. Step 2 is where we have to find the particular solution, which I like to write as x sub p. And we wrote down the formula for it last night, and I'm sure everybody was thinking about the midterm and everything, so it's been a little chaotic here, so I won't blame you if you don't have it down yet. But the formula for the x sub p is just the fundamental matrix times u. Where I'll write down 2 things. First of all, the fundamental matrix, this is this capital X. Capital X is just formed by putting the complementary solutions into the columns of the matrix. So in this case, what that would be is the first column would be 2 and 1, and the second column would be e to the 3t and 2e to the 3t. So that's capital X, right? That's my so-called fundamental matrix. So we have to write that down, the fundamental matrix. And then the other thing is we have to know what U is. Does anybody who was paying attention last night at all happen to remember the formula for U? It's an integral of, anybody remember? It's okay if you don't.
What's the first letter?
It's actually x inverse times b. Okay. You know it has to have the b in it, right? We haven't used the b so far. Yeah. So it's x inverse times b and then the integral of that. Does that make sense? Let's just find the inverse of this fundamental matrix as long as we're at it. So you see, we've got to know the formula for the inverse of a 2 by 2. So I can go on record right now and tell you I'm not going to make you do a 3 by 3 of these kind of problems, because no 3 by 3 is way too awful, right? So for a 2 by 2, the way I get the inverse, if you remember, I take the determinant here. What is the determinant of this matrix?
3e to the
3e to the 3t.
It's 4e to the 3t minus e to the 3t, right, which is 3e to the 3t. So I put that on the bottom, so 1 over 3e to the 3t, and then I have to multiply by the matrix where I swap the diagonal numbers, so 2e to the 3t and 2 looks like that, and then minus signs on the other two numbers. Okay, so it's going to look like that. Okay, and now that can be simplified a little bit further. What I'm going to do here, I can leave the 1/3 in front, I don't mind doing that. But what I'm going to do here is I'm going to divide each entry by e to the 3t. So when I do that, I'm going to get 2 and -1 on the top line. And then I'm going to get I'm going to get negative e to the minus 3t. And then I'm going to get 2 e to the minus 3t. Everybody agree with that? So far so good? So this is the inverse of the fundamental matrix. That has to be, according to this formula, the next thing we need to do is multiply that by b. So b, just to remind you, b is this thing over here. Right? This is b. So let's go ahead and work that out. X inverse times b is, we have 1/3 of the matrix 2, -1, and negative e to the negative 3t, and 2e to the negative 3t. That's my x inverse. And I'm going to multiply that by the b, which was given at the... b is always given, right, in the original problem. So 54t e to the 3t and 9e to the 3t. This is the calculation we have to do. Okay, so I've got 1/3. And now I've got 2 times 54. All right, so here we go. 108t e to the 3t, and then minus 9e to the 3t. Does everybody see I'm going across the row and down the column? Right? On the second row, I've got, e to the negative 3t times e to the 3t is just 1. So I'm just going to get negative 54t, and then plus 18. 2 times 9 is 18. Everybody seeing that? Let's divide everything through by 3 before we go any further, just so I have smaller numbers. Okay, so 108 divided by 3 is 36. So 36t e to the 3t minus 3e to the 3t. And on the bottom line, 54 divided by t is, 54 divided by 3 is 18. So negative 18 plus 6. Okay? And that is what now has to be integrated. I'm just going to tell you what you get here with the integral. So the u is just the integral of that. It's just the integral of that. And so when I integrate it, when I integrate this thing, on the second line, let me do the second line first. What's the antiderivative of negative 18t plus 6? Negative 9t squared plus 6t. Do I need plus c on the end of this?
No.
Not at all in this section, because we're just looking for a particular solution. Right? Okay, so that's the second line. Now, as far as the first line goes, you got to use integration by parts to integrate t e to the 3t, which we have almost never done. I guess you've probably had to do a couple of them somewhere along the line this semester, but I don't want you guys getting wrapped up in studying a whole bunch of integration techniques. That's not really the thing you should be focusing on. So I'm just going to tell you what the answer is, if you don't mind. That'd be all right with everybody? I'm going to simplify it. So this is going to save us 5 minutes of time, which would be good, because then I can spend 5 minutes doing something more interesting, which is the antiderivative of this. I'm going to factor out e to the 3t. Sorry for the small writing, I'm just trying to squeeze this in here. So e to the 3t is factored out, and you end up getting 12t minus 5. That probably doesn't look too obvious to you from where you're sitting right now, but after you simplify it, that is what it comes out to be. And again, no plus c on the end of it. Are you guys willing to take my word for that part? It's not that's not the crucial part. I probably wouldn't give you a problem where you had an integral that was anything difficult to come up with at all. Okay, so that then becomes u. So then I go back to what we were trying to find. You've just got to remember all the steps. That's the only thing. The particular solution is just x times u. So x sub p is the following thing. We take capital X, which is written on the other board there, 2 and e to the 3t, and 1 and 2e to the 3t. I have to multiply that by this vector that I just wrote down here. E to the 3t times 12t minus 5 and negative 9t squared plus 6t. All right? And let's see, after I work that out, what am I going to get out of that? Let's see. It kind of needs to be, you kind of have to multiply this. This is a 2 by 2 matrix. By the way, be careful. This almost looks wide enough to be a 2 by 2 matrix, but it's just a column. Right? So you're going to take 2 times this plus e to the 3t times this. And both of those terms are going to have e to the 3t in them. And then it's just a matter of simplifying what's being multiplied by what. So you're going to have a negative 9t squared being multiplied by it right
Plus
here.
18t.
And then how many t's do you have?
24.
24 right here, but then plus 6 more right here, right? So that's actually 30 t's. And then the constant term, which is going to be negative 10 here, right? I guess that's it. Yeah, negative 10. So it looks something like that. And on the bottom line, we can also factor out e to the 3t. And we're going to get, let's see, negative 18t squared, I believe. Yep, that looks right. And then how many t's do we get? Well, we've got 12 of them here, and another 12 of them here, so that would be 24 of them. So 24 t's. And then my constant term again is negative 5, and that's it. So it's just like that. Okay? You could factor out this e to the 3t from the vector if you wanted to, but you don't have to. Anyway, so that's basically the final answer. I guess I'll go ahead and factor it out. So you get e to the 3t times negative 9t squared plus 30t minus 10 and negative 18t squared plus 24t minus 5. Clear enough? So am I totally done?
No.
What's the very last thing that I still need to do? Add the particular solution we just got to the complementary function that we wrote down when we were here. So just put that all together and we'll be done. Let me just put it right here in the middle. How's that? So x of t equals, do like a vertical equation here, c1 times 2,1 plus c2 e to the 3t times 1, 2 plus e to the 3t times negative 9t squared plus 30t minus 10 and negative 18t squared plus 24t minus 5. This one was probably slightly harder than average only because the b that was given wasn't so simple. You actually have to do an integration by parts from here to here. But guys, what you want to be making sure you're confident on is the process. The process. break it down, 3 steps. The complementary